In this video, we're going to take a look at the hierarchical clustering methods, which are probably the most intuitive way of grouping data. In clustering, we have n objects. In the case of market segmentation, these objects are the consumers, and we want to divide them into k groups. There are two possible starting points for hierarchical clustering. We can treat all the consumers as one big market segment, where k, the number of groups, equals 1. This is illustrated in the left picture. At the other extreme, we could put each consumer in their own segment. In this case, k equals n. The number of consumers is the same as the number of segments. This is illustrated in the right picture. If we start with all consumers in one large segment, we can use divisive hierarchical clustering methods to split this one large segment in a larger number of smaller segments. We start by splitting one segment into two. Then each one of those is again split into two, and so on. This process continues until each consumer has their own market segment. If we start with each consumer having their own segment, we can use agglomerative hierarchical clustering methods to create fewer, larger segments. We do this by calculating how close each consumer is to all other consumers. Then we put the two consumers which are closest to one another together into one segment. Once there are at least two consumers in one segment, we need to change from calculating distances between consumers to calculating distances between segments. Underlying both divisive and agglomerative clustering is a measure of distance between market segments. This measure is determined by specifying a distance measure d between two data points x and y and selecting a linkage method. The linkage method specifies how distances are measured between segments. The three most commonly used linkage methods are single linkage, complete linkage, and average linkage. As you can see in the picture on the left, in single linkage, the distance between the two closest consumers assigned to different segments serves as the distance between segments. Complete linkage does the opposite. It uses the distance between the two consumers assigned to different segments who are furthest apart from one another. And average linkage calculates distances between all pairs of consumers assigned to different segments and uses the mean value. Note that these linkage methods are independent of the actual distance measures, so we can use them with Euclidean distance or Manhattan distance or any other distance measure of our choice. There's no correct combination of distance and linkage method. The choice of the linkage method affects the final market segmentation solution. Single linkage, for example, can find non-convex, non-linear structures like the spirals in this image. In situations where clusters are not well separated, and this means in most consumer data situations, the single linkage method can lead to undesirable chain effects, where two groups of consumers are merged into one market segment just because two consumers, one in each group, are close to one another. A popular alternative hierarchical clustering algorithm is word clustering. It is based on squared Euclidean distance and uses the weighted squared Euclidean distance between cluster centers as distance measure between groups. The R function hclust has two versions implemented, where either the Euclidean distances or the square Euclidean distances need to be provided as input. Results of hierarchical clustering methods are typically presented as dendrograms. You can see a dendrogram here. It has its name because it looks like a tree. What it shows us is the exact history of mergers or splits between the two extreme cases of all consumers being in one segment on top, and each consumer sitting in their own segment at the bottom. Based on this dendrogram, the data analyst has to make the decision which solution to choose. Cutting the tree at a higher point results in fewer, larger segments. Cutting the tree at a lower point results in more, smaller segments. Optimally, we are looking to cut the tree at a point where the vertical lines are long. In the case of this dendrogram, you can see we decided to use 6 segments because the 2-segment solution, which has the longest vertical lines, did not lead to distinct enough segments. In general, it's not easy to decide where to cut the tree, especially not for consumer datasets, which typically do not contain naturally existing market segments. Hierarchical clustering methods should be seen as a set of techniques which can reveal different features of the data. Given that market segmentation analysis is exploratory by nature, it is always good to run a few different extraction methods.